Hi class, this is Dr. Nerz. I'm in my lab. I hope I'm in this camera shot. I don't really know how to work the camera backwards. I'm going to continue what was sort of a semi-horrendous video that I started yesterday, only because I was having all kinds of problems that we didn't have in the first run through. We had run it earlier in the day and everything had been fine. Then when we tried to run it on the video, it was like all craziness broke loose. Okay, so I want you to remember that the column is a model for your TLC plate. And I'll try to explain what I'm doing as I'm going along, and I'll try to show you as best I can using the camera, but I don't have a camera person today or anything to hold up the camera. And as you know, I do these on my iPhone, which is pretty low level, I suppose, but I think I can get some better close-ups if I do it. So I'm going to send you this video, which I call the Julia Child. I don't know if anyone ever saw the very old Julia Child show. You guys are too young, but you might have seen it in Julia and Julia, and I always think of when I make a mistake, the way Julia Child drops the chicken on the ground, just picks it up and kind of uses the, what is it, the 5-second rule or the 2-second rule, and she just keeps cooking with the chicken. So that's kind of what that video is like, but it shows you a lot of how to do it. But I'm going to do it again in a more accelerated fashion. Now again, realize the silica gel in this column is going to mimic what you saw on your silica gel plates, and it's a large-scale methodology of separation. Okay, so I'm going to turn around now so you can see the column. Okay, so this is what our columns look like. Most of them are blue. They have a blue bottom. And what I'm suggesting to everyone is that you put a needle on the bottom. If you will recollect, that's one of the problems I had when I was running it. It was running too fast. And then there's the top part of the column. These are very small columns. Notice it is held up by a clamp, and it's sitting over a, not anymore. See, this is my weekend. I'm going to put my needle back on. Trust me, when you do this, things will happen. Anyway, I'm putting, as you know I love, a graduated an Erlenmeyer flask underneath to collect any effluent that comes off the column. Now the thing I said to do first in doing your column was to pour a little bit of sand into the column, and you will recollect that I used a little piece of paper. This is really one of Andy's little papers, and I'm pouring just a wee bit of sand, and I mean a wee bit of sand into the paper, and I'm just using the paper to shoot the sand in. Typically, and this is just regular old, very purified sea sand, typically the sand is used as kind of a barrier between the bottom of the column and normally what is glass wool in the bottom of the column, but this particular column does not have glass wool. It has a little glass frit in it, not unlike what you saw in your sinter glass funnels. Okay? So then the next thing I said to do was to take dichloromethane and fill up the column. Okay, with dichloromethane. Now we're going to see how this one runs. I've made a few adjustments to try to slow things down. One adjustment I've made is I am putting more sand in the column. The other adjustment I'm making is I am putting a smaller needle on the bottom of the column so it flows slower. And I'm going to show you some other methods to make it flow slower, because it's actually important that it flows slower. So I'm putting quite a bit of dichloromethane in. Now, what if we want to stop the column? You might wonder, how am I going to stop this column? Kind of shoving my needle up. It still is running very, very, very quickly. The way I would recommend stopping the funnel is take one of your handy pieces of handy adapters like this one, or you could even use a rubber stopper like this and just shove the needle into it, which I've done. It's still running very, very, very slowly right now, but at least it's not running all over the place. And there are ways to get it to stop completely. Okay, I'm going to put my Erlenmeyer under this because it's dripping a little bit. But that slowed it down considerably. Now what I want to prepare is my silica gel. This is about 6 grams of silica gel in a small 125 milliliter Erlenmeyer. What I'm going to do to it is add a whole bunch of dichloromethane, and the procedure you're going to receive from me later in the day I suggest that you put about 30 ml in. The reason I'm stopping is this is cramping my hands up a little bit, so I'm going to switch jars. I'm just putting in enough dichloromethane to create a slurry, and we showed you the slurry yesterday. I think it's good to see this again. My method of stopping this was not perfect, but realize I'm working with one hand. We're praying right now no one walks in on me while I'm doing this, because they will think I'm crazy, because I'm making a video in my lab by myself. Okay, so what I've done is I've added dichloromethane. Now, why dichloromethane again? I'm using dichloromethane because that's the solvent that we're using for the experiment. So I'm hoping people will watch this before lab, and this will save us doing a demo at the beginning of the lab. Okay? Now, as I showed you before, if you look at this and kind of watch it, you can see there's silica stuck on the sides of the glass. But if you watch it, the silica gel that's in the solvent is kind of suspended, and the longer it sits in the suspension, the more it settles down. Okay? Now, what I'm going to begin to do is slurry pack the column. This means that we're going to pack the column wet, and this is how a lot of chemists pack columns. Now again, my column's drizzling a little bit. I slowed it down. We do have this problem that with our little inexpensive columns here, they're not that inexpensive, by the way. They're about $20 or $30 each, but with our little inexpensive columns here, we have a problem controlling the flow rate. Do you see the liquid? That's the liquid right there. So I'm going to start slurry packing, which means I just keep swirling this flask and then pouring it in through the top of the column. So I'm pouring it in. And I'm not even the least bit worried about this because it's running. But because I want to make it run faster, I'm going to take this off for a minute and let it run. I'm going to let it run. Now, if I want to slow it down now, rather than using that piece of rubber, I'm going to use the cap on the top of the column. All these columns have caps. And if you put the cap on tight enough, it will slow down. Let me see if I can get it to stop. Okay. Now my needle fell off again. Okay, see the cap? So just hold on 1 second here. Okay, sorry for the delay. Okay, you can see this here. I have to say my cap is a little difficult. But it is flowing in, and if you look at it, you can see the silica gel settling right about there, down to the bottom. The liquid flowing out at a ridiculous rate, and I'm going to have to stop it. But you can see my liquid solvent on the top. And by the way, you can constantly recycle solvent. One of the goals with this is you never want this to run dry. So I'm going to pour more in. I want it to be a little taller, so I'm making it a little bit taller. Okay? If it looks like it's running dry, just take solvent from the bottom and pour it back into the top, because that's all that is dichloromethane on the bottom. If you were to use a different solvent system, like say you put a little bit of methanol in, you could easily just make up that solvent at the beginning, you know, maybe 1% methanol and dichloromethane, and that's what you would be using to pack. Okay, so my column's still kind of settling here. Okay, now how am I going to slow this thing down? This has been my dilemma this weekend because they've been moving kind of quick. So I'm going to try again with my cap. The cap, if on tightly, will slow it down, and this actually did slow it down a little bit. It slowed it down to a point where it's actually dripping now instead of running full force. If you really ram the cap on, it will really slow down. Okay, so I'm going to bump out for 1 minute again, just to show you that. And I find with the cap, it takes a couple minutes for it to slow down. Now, can you see the silica gel settling there? I actually made a rather tall column. We're going to make columns that are maybe about half this height. Now, this is the height column you would make if you were trying to separate compounds that had very, very close bands on TLC. Now, I can't let this thing go dry, so I have to keep filling it up. Alright, so I'm at this point now where I got to control the flow a little better. So to control the flow a little better, I'm going to put a rubber stopper on the bottom. This is another way to do it. Okay? And in fact, this is probably the way to do it. Alright, do you see what I did? I just took a rubber stopper and I just rammed that needle into the rubber stopper and it has stopped flowing. Alright, now what the column is now packed. Again, the important point is never to let that silica level run dry. You just don't want that to happen. One thing that can help you is to put a little buffer zone on top of the silica gel. My buffer zone is going to consist of a tiny bit of sand again. So I'm going to show this to you, okay, if you're watching this. Alright, that's the top of the column. Sorry about my shaky hand here. I don't have my good son doing this. But you can see I just put a little sand on the top. That sand gives you a little buffer zone in case you make a mistake. Now again, this is a pretty tall column. Alright, this is probably more like a 9-gram column or a 7-gram column. This is the kind of column you might pack when you're actually separating your warfarin. When you're separating your compounds, your aldol compounds, I would say you can work with a column about half this height. Okay? Realize also we have much taller columns. Okay? Now the next question is, how do you load a sample on? Well, the way you load a sample on is you let the liquid run down to the sand level. So I'm going to let the liquid run down to the sand level. Now how am I going to do that? Well, to do that, I got to take my little cork off, my little stopper off. So I'm going to gently do that, if that's possible. You might need your partner for that. So I'm going to let it run down. So I'm letting it run down on the top. And when I see that liquid level get to the level of the sand, I'm going to throw the cork back on. So it's still running down here. The column's really filled up, so it's working its way down. You can tell I don't take a lot of movies because I never have the camera in the right spot. It's coming down. Coming down. Remember, we never want it to go dry. It's actually running at a decent rate right now. Pretty happy with it. Pretty happy with my column. Okay. So let's see if it comes down. My arm's getting tired. Let's see if it comes. Come on, liquid. I don't want to be surprised by you. So I'm using that sand again as a buffer. And what I'm going to show you next is how to put the sample on. And then how to elute it. And I've come to the conclusion, even in this short period of time, that the best way to work is to take a rubber stopper and shove it onto the needle. It'll stop the column. Alright, it's coming down now. I can see it now. You see it? So I've got to stop it. So I'm going to stop it right now. Right now. Okay, so I have stopped it, I hope. I stopped it just above the level of the sand. I can see the liquid. Now how do I load a sample? Okay, well I have a little tiny sample. It's nothing to write home about, just a little, it's a little warfarin sample. It's not the most beautiful thing ever, so I'll show it to you. It's a little tiny vial of a yellow liquid, and I'm going to load it on, and this will not be dissimilar to what you'll be doing. What I'm doing right now is I'm just preparing a pipette to load the sample. And I'm putting my sample, I'm just going to put my sample, okay, I'm going to put my sample in my pipette and load it on. Okay, so to show you how to load it on, okay, my sample is in a pipette. I like to drizzle the sample around the edges of the column, as I've shown you there. Then what am I going to do? What I'm going to do is pull the rubber stopper off on the bottom and let it start running again, okay? And it's going to start running into the column, and you'll actually see the color entering into the column. And you guys are lucky this week because you've got a colored compound. Okay, I've reached that point. Gotta stopper it up. I'm going to tell you what's going to happen if you don't stopper it. If you don't stopper it before it gets below the sand, you're going to get air pockets in your sample. Then what I typically do is I run a little bit of solvent around the edges to kind of rinse my compound into the solvent. Do you see how it's like lightly yellow on the top and really yellow on the column? Okay, and I'm going to start collecting again. So I'm letting it run in again. And again, all I'm trying to do is clean the sides of the column off. And I'm going to get it right down to that sand level. And I'll tell you, beginners need sand. Okay, I got to stop it again quick. I got to be on my toes here. You got a whole team. Okay, and you're not going to be running a camera. Can you see that my sample is already separating the way it would on a TLC plate, but everything's upside down? Okay, so what would I do next? What I would do next is I would clean it again. So I'm using the spray bottle. I'm just putting a little more dichloromethane. You could have a beaker with a little dichloromethane in it. And I'm just going to let it run off again. I'm going down to the bottom. I'm pulling that off. And I'm letting it run into the Erlenmeyer a little bit until it gets down to the sand again. Now at this point, I would load the column with solvent to prepare to elute the sample. So I'm letting the solvent come down. It's coming down, as you can see. I'll just show you it coming down. See it coming down? So I'm at a point where I can load it. It looks nice and clean. It looks like all the samples on the column. Okay, so what did I just do? Just put the rubber stopper back on. Can you see that? That rubber stopper? Okay. This is my collection. Now, at this point, if your column's taller, or if you have a smaller column, and you guys will, like I said, in class, most of the time, depending on what we're trying to do, we will probably have smaller columns with this, but you could certainly work with a column this big. I think I had maybe, I kind of guesstimated my silica gel, and I had about 6 grams, something like that. So just hold on one sec, okay? Because I'm going to go get you, I'm just going to show you how you collect the sample. Okay, I didn't want to shut this down because I didn't want to stop. But basically, the way you collect your sample is in a test tube rack like this. So we have these special test tube racks, and you collect your sample in fractions. So you could have this test tube rack filled, maybe 2 rows, I would say, with these little tiny test tubes that we're going to have available to you in the lab. And what you're trying to do is run your compound off the column and collect it down here in small fractions. So for example, and you might have to lower your column to do this properly. My column's up too high, so I'm lowering it. This is one of those days I wish I had 3 hands. Okay, I just brought my column down. Now, just to show you, and I'm going to destroy my column now. Okay, so here's my column. There's my compounds. They've already started to separate. Do you see that? There's one that's staying close to the origin. That's like the origin on your TLC plate. And there's one that's moving more with the dichloromethane. So down here, I'm pulling my cork off. This is crude, but it works. Okay, it's starting to run. I would start collecting the sample in the test tube. And then what you have to constantly do is refill the top of your column constantly to keep the liquid volume up. because the column can never go dry. All right, I would recommend collecting about, I would say, maybe a half of one of those tubes, maybe a third of one of those tubes. So I've collected about a third of a tube. So I switch to the next fraction and I start collecting. What am I trying to do? What I'm trying to do, because I can't really see every molecule that's coming off. I can see this yellow one moving pretty fast, but I can't see every molecule that's coming off. I want to get the sample separated into maybe 20 fractions that I can study by TLC. All right, so again, I would let this one fill to about the same level. Okay, then I would go to the next one. All right, now my test tube rack is not all filled up, but if it were, I would continue filling. And don't forget, right, you gotta keep filling the top. If you don't keep filling the top with your solvent, you will go dry. If you get dry, you get air pockets in your column. If you get air pockets in your column, you have a big problem. You get very poor separation. Okay, so this is a pretty good column. It went pretty well. Like I said, I was running the camera with one hand and doing the experiment with my other hand. That's not the greatest way to do it. But I don't know if it makes sense that if I collected enough of these fractions, these compounds that you're seeing here separating out, and this yellow compound's moved all the way down here, these compounds that you would get separating out would end up in different test tubes. And if you spotted those test tubes versus your standards, you would be able to figure out which test tubes have your product in it. And when you figured out what test tubes had your pure product in it, all you'd have to do is rotovap it down and you would have very pure product. So that's kind of our goal. Okay, so I hope this made some sense. One thing that's really important with these racks is these don't belong to us, so take good care of them. Clean your test tubes at the end of the day because we don't have an infinite quantity. And make sure you label your test tubes so you know which one is which, because it's very important to know the order. And don't forget, you have to constantly fill your column. I'll probably leave this column up so that you can see it, but this tape is going to be in lieu of a demo, I believe. Okay, thank you.